Worksheet 4E, stress concentration, determine the maximum actual load. So that is P max in there in the problem. The structure shown below can support. Use the factor of safety with respect to the ultimate stress. Factor of safety 2 on this brittle material, and the material is gray cast iron. So this is stress concentration and gray cast iron. So even the problem don't give you the ultimate stress, you can be able to find out from the appendix B. From the appendix B, we can find out what is the ultimate stress of this gray cast iron. So let's go to the reference and appendix B and cast iron, gray cast iron, and because it's cast iron is a brittle material, so they define about the ultimate strength, and with the tensile, you can see here 25 for gray cast iron there, and that is KSI, so 25 KSI, and you can see there for gray cast iron. So go back to here, we have it from the appendix B, we have that equal to 25 KSI, and appendix B of the book. And with the respect to the factor of safety that the problem gives us, the factor of safety is equal to 2. That the problem with us. So if you recall, this is for the with regard to the ultimate stress. So it will be for factors of safety for the stress. So it will be sigma failure, the failure level over the allowable level. And in this case, they talk about the stress, so we put it sigma. So from that we can have sigma allowable it equal to that one actually is sigma failure with the ultimate stress. So from that we can have equal to 25 divided by 2 for factor of safety. So we have it 12.5 KSI. So that is the allowable stress on this brittle material with the gray cast iron. So from that we have to check what is stress. So there is a few things that we need to check. The first one, you need to check what happened to the average stress occur in the smaller cross section here. We don't need to check on the big cross section because that for sure it will be less stress. And then we have to check what happened at the fillet in here. What happened for the stress concentrated at the fillet, and then stress concentrated at the hole in there. So that is the 3 check we need to do. The first one is as sigma average for the small cross section of the two. So let's do it there one by one. The first we have to check at neck. Okay, so we'll check at the neck, smaller one. So in this case, let me put that down is position 1. Position 1. This is the position 2 that we want to check, and position 3 that we want to check for this problem. And from that we have for the next, which is position 1 at the neck. So what we have is the sigma average less than the sigma allowable. So let me make clear the allowable. We can call that a sigma ALL, which is allowable. So make it shorter for us. And sigma average is P over A, and you know, less than sigma allowable, which is 12.5 KSI. So P over A for the next number 1, so that you can see P, it will be less than or equal to 12.5 times the areas. The area in here is 1 inches by 3 inches time 1 inch by 3 inch for the neck. So from that we can have P less than or equal to 37.5 kips. So what does that mean? To be able to sustain the load for this given size of the gray cast iron, the load P will not exceed 37.5 kips. Otherwise, the neck will be break. Right? Now to check the position number 2, which is the fillet. Right? Check at the fillet. Check at fillet. And when check at the fillet, we use the sigma max because that is the stress concentration at location 2 in there. So that means we check at the location number 2. So from that we have the equation is sigma max concentration at the fillet is equal to the stress concentration factor K times sigma average, because K is equal to sigma max over sigma average, and this have to be less than the allowable stretch on that material. Now for the fillet, what we need to find out K of the fillet. How can I find out K? We have to use the chart in the book. So K for fillet, what is that? It depends on several factor in here, which is go back to our note. Remember stress concentration, so K equals sigma max over sigma average. And for the fillet, which is this finger we are talking about, we need to do the R, which is the radius of the fillet. Okay, this lowercase, which is the width of the neck, and the D capital, with the width of the big one. Okay, so let me find that out, that ratio, before we go back here to use the chart. So from the finger we can have radius at the fillet equal to, as you can see here, 0.42 inch. See there. And then we have D lowercase 3 inches. And D at uppercase is 6 inches. D uppercase 6 inches. D 6 inches. So from that we can find out the R over D is equal to R over D small, so 0.42 divided by 3. So we will get 0.14. And then D capital over D small, it will be 6 over 3, it will be 2. And from that, go back to the finger, right? Go to the finger here, that finger there. So D here, that D, as you can see, you have to choose that curve, because that 6 over 3 equal 2, and the R, the radius of the fillet of D small, equal to 0.14. So 0.14 is somewhere here, somewhere there. Okay, so that go back up, go up to there, to that. Okay, there, and down to there. So with that, this is between 2 and 2.2, and it's more close to 2.2, so that is about, as you can see, that point K is about 2.16. So with that, we can go back to the problem. We can see that use the finger, which finger here? Finger 252. Okay, we can have K equal to 2.16 from figure 252b. 252b. Yep. So with that, go back here, we have it. So continue with the fillet. Continue. Continue. We have sigma max. So rewrite it. Sigma max equal to K sigma average. So we have it 2.16 sigma average P over A. So it will be P over A. A in this case, as you can see, it 1 inches. 1 inches times 3 inches for the neck here, and that have to be less than sigma allowable, which is 12.5 ksi. So from that we can have P less than 17.36 ksi. So to make sure the fillet will not break, then the load P maximum is 17.36 ksi. The last check is position 3 when we have the hole there. Okay, so that go to the last check that we have is check at hole. So when check at hole, we still have the same equation, sigma max equal K sigma average, and K in this case is the hole, right, and less than sigma allowable. So now see sigma average the same. Sigma average we need to find out in that cross section. It's not the same, but the K also not the same. So let's go back to the whole situation with the reference here and with the whole that you can see. So we need to find out the D capital. So D capital in this case the 6 inches, and the D small. So you can see half D. So it basically the D here. You can see that from D here. The D lowercase, it should be equal to D minus what? Minus the diameter of the hole. Okay, and that it will be 2R. That is D small. And then we make it 2R over D, and then go to the table, go to the diagram and find out for the K. So let's go back to here. We will have to find out the K for the hole. We need to find out what? First, we need to have the radius of the hole. In this case, the diameter is 0.2 inch. So the radius is 0.2 divided by 2 equal to 0.1 inch. And then the D is equal to, the D here, as you can see, go to the thickness, not the width. So that D here equal to 1 inch. Because they cut the hole on this section. Let me put down there, raw finger. So that you can see now the hole in that cross section, the hole there. And that one, the D capital, is really the D capital. And that only the thickness of that one is 1 inch. 1 inch. 1 inch. Not 6. Not that one. But because the hole, as you can see, form on the other side. If the hole go there, then the D capital is 6, right? But that one on the side. So from that we can go back down here. It's 1 inch. And this is 1/2 of D. This is 1/2 of D. So each here 1/2 of D small, 1/2 of D small, based on the definition. So from that we can have the D will be 1 inch, and then the D small equal to D minus 2R, right? D minus 2R. So 1 minus 2 times 0.1, so it will be 0.8 inch. So to make that use that finger, we need to find out what is the ratio of 2R over D, and that is 0.2 divided by 1, so it will be 0.2. So from that we can go back to the finger. Go back to the finger there. It takes some time to load. So go back to the finger there. It will be 0.2. 0.2 here. So you have 0.2 for 2R over D. Go up to this one and get down to that. So that, as you can see, we have the K for the hole in that one is 2.50, because that's something between 2.4 and 2.6. So from that we can go back to the problem. We can find out K in this case equal to 2.5, and that based on the from finger, which finger, 252A, 252A, finger 252A. So from that we can go ahead to find out the sigma max and less than sigma average. So from that we have sigma max equal to K 2.5 P over A, P over finger 252A. So P over A, and in that case A is, you can see from cross section here, it will be equal to the cross section that we cut through here. So that will be the D, half D, half D. So it will be D times the 6. So from that we can have the areas going down here. It will be 6 inches times 0.8 inches, and this have to be less than sigma allowable 12.5, and that we have P less than 24 kips. So we check 3 scenarios. Position number 1, which is the necking, sigma P, the load, maximum load can carry is 37.5 kips. For the check the fillet, position number 2, it have to be 1736 KSI. And the last one, position number 3, which is the hole here, the maximum loss equal to 24. So compare this, as you can see, to be safe, P have to be less than 17.36. So the small out of those 3. So as you can see, P max, from that you can have P max equal to 17.36 kips. And in this case, you can see that either fillet govern, because that govern. That basically the maximum stress located. So that is the answer. So that for the stress concentration problem.